Chapter 21, Preparing a Buffer. How many moles of ammonium chloride are needed to make 2 liters of 0.1 molarity ammonia solution to form a buffer whose pH is 9? So right away when you see this problem you should go, ooh, buffer. I learned an equation that has to do with buffers. That equation is the Henderson-Hasselbalch equation, or however you pronounce that complicated name. So step 1, we're going to follow our usual steps at the beginning. Identify the major species. So we have 2 of them. We've got ammonia, which is a weak base. And then we have ammonium. Oops, I don't know why I switched colors there. Ammonia. Whoa, 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 whoa. I'm getting too excited. So ammonium chloride, which is its salt. And we know it is the salt of ammonia because if we were to write out the reaction, which we're doing next, you would see that they are linked. So we know that ammonia plus water will react reversibly because it's weak to form ammonium and hydroxide. And people ask me, well, how do we know? Well, you'd have to memorize that ammonia is a base, for one. And we know that bases attract hydrogens. And if you add a hydrogen to ammonia, you end up with ammonium. So now let's write the equation for the salt. And we know salts completely dissociate in water as long as they're soluble. And you end up with NH4 plus Cl minus. So here's the key here. These ammoniums that are coming out of ammonium chloride are going to be pumped into the solution in order to beef up the product side of the reaction. And we know if we beef up the product side of a reaction that is at equilibrium, it is going to shift that away. And so the goal here is to start with a buffer that not only has ammonia in it, but also has ammonium. And we want to figure out, well, how much ammonium do I have to put into here in order to make sure I have a solution that has a pH of 9? So what we're going to do then is we're going to, this is now step 3. We're going to solve using the Henderson, is it S-E-N? S-O-N. Henderson, H-A-S-S-E-L-B-A-L-C-H. Okay, there. The Henderson-Hasselbalch equation. So this equation, let's see, we are working with bases, so I'm going to write the base version of this equation, which is POH is equal to PKB plus the log of the ion over the original substance concentration. This equation also works if you're just using moles, if you need to. So you could think of this as the salt over the weak base. That would work. Okay, so do we know the POH? Not really, but we do know pH. So POH is equal to 14 minus the pH. So our POH is going to be equal to 5.00. Okay, so I've got that. Now, 5.00 is equal to the pKb. So what does the P mean here? The P means negative log. All right, and what is the Kb for ammonia? That is something that you can just look up in a chart or would be given to you. Again, you don't have to memorize these numbers. So I'm plugging in the Kb. which is 1.75 times 10 to the negative 5. I'm just telling you that. It would either be given in your problem or you would be given a gigantic chart full of these values. Okay, plus the log of the concentration of our ion, the salt. So in this case, our ion is ammonium, and the original weak base was ammonia. So I'm guessing some of you are thinking, well, why didn't we use hydroxide? Well, we didn't use hydroxide because we're trying to link ammonia to its salt, and the salt is providing us with ammonium, which is something that ammonia becomes. So they should be similar to each other, what goes in these parentheses. Now I'm going to erase what I have for ammonia. I'm going to erase NH3 with my tiny little eraser. There, that's better. And I'm going to plug in the concentration of ammonia that I have. So what is the concentration of ammonia that we're working with here? It is 0.1 molarity. Okay, cool. So now this is going to require some log skills. Let's first add log of 1.75 times 10 to the negative 5 to both sides. Okay, so let's see what that comes out to be. 5 plus, and you could be practicing this along with me if you haven't worked with logs very much. 5 plus log of 1.75 times 10 to the negative 5. Okay, so we have 0.243. I'll deal with sig figs later so I get a more accurate answer. 380,487. Okay, that is equal to the log of the concentration of ammonium over the concentration of ammonia. All right. So at this point, I think most of you have learned how to take logs apart. So if you have division, you could put this as a note. So division in a log is subtraction outside. So up here, I'm going to rewrite this. So 0.2430380,487 is going to be equal to the log of the concentration of our ammonium minus what it was being divided by, which is the log of 0.10. All right. Let's add this to both sides. So plus a log of 0.1. Interesting. That number did not come out. Well, let's see what happens. So I've got here, this is real-time confusion. We'll see what happens. 7, 5, 6, 9, 6, 1, 9, 5, 1, 3. So if this video ends up getting posted, that means that this worked out. Pretty sure it does. So now we have the log of NH4 plus. All right, how do we get rid of logs? Well, we know this is log base 10. If they don't write the base and it's a log, that means it's log base 10. So I can use 10 to cancel those out. So you actually end up with your answer this way. The concentration of ammonium ions that we want to have added to the solution is equal to 10 to the negative 7 or negative 0.756 blah 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 blah. You end up with 0.175 molarity. Interesting. Okay, well, I want number of moles of ammonium chloride that I need, so let's cancel out the moles that are hidden within this molarity. I'm going to multiply it by the volume, which is given back here. So I'm going to multiply this times 2.0 liters. That cancels out with the liters that are inside of molarity. So 0.175 times 2, you end up with 0.35. And let's see how many sig figs. This whole time we should have had 2, so 0.35 is good. These are how many moles of, well, ammonium is 1-to-1 with ammonium chloride, so I can just go straight to NH4Cl. So, in order to create a buffer that has ammonia and its salt, ammonium chloride, that has a pH equal to 9, I need to supply 0.1 molarity ammonia and 0.35 moles of ammonium chloride. So remember, when you are using a buffer, when you're creating a buffer, you need to use the Henderson-Hasselbalch equation.